Hey, this is Mrs. Marquette again, and this is video 2 for day 3. So if you missed video 1, go back and watch that. In the last video, we talked about simplifying some square roots. What we're going to do in this video is solve some problems using square roots. So we'll have to use some of those other skills, but I want to go over one thing before we start actually solving. So if we have the problem x squared is equal to 9, we want to know what makes that equation true, because that's what a solution to an equation is. So I want to know what times itself twice is 9. And you might think, okay, that's just 3. But we've also talked about the fact that that squared means I'm going to have 2 answers. So we want to think about what is the other number that could possibly give us 9 when I multiply it by itself. And you might have already figured that one out too. It's negative 3, because negative 3 times negative 3 is in fact 9. Check. So when we solve problems that have square roots in them, what we can actually do is use something to undo a square, and that's a square root. So my square root and my square undoes itself, so I'm left with x. On the right side, the square root of 9 is just 3, but we've got to know that there's a positive answer, there's also a negative answer. So whenever we take a square root, we are going to make sure that we remember to put plus or minus because of the fact that a negative times a negative is a positive. So that's going to come up in every single problem, which is why I wanted to go over it here. When we solve using square roots, we can really have 3 steps. First of all, we want to isolate whatever is squared. I'm going to say isolate the weird thing, whatever the something squared is. Whether that be x squared, like it was up here, or x minus 8 squared, we just want to get the square on the outside. And then we're going to take the square root of both sides. And remember to do our plus and minus, and then we're going to get x by itself. This is going to come back again now, PEMDAS backwards. The first thing we look for is something to add or subtract, then multiply and divide, then deal with our exponents. Today our exponents is going to be our x squared, and then do the parentheses. So let's see what that looks like on number 9. I have 2x squared plus 1 is equal to 17. PEMDAS backwards says the first thing I got to do is deal with things that are added or subtracted. I have a plus 1. The opposite of a positive 1 is negative 1, so I subtract 1 from both sides. And we get 2x squared is equal to 16. Okay, now we have actually something multiplied. So keep going up PEMDAS backwards. The opposite of multiplying is dividing. So I'll divide both sides by 2. X squared is equal to 8. And now here's kind of the money step, the new thing for today. We've isolated x squared. We've gotten the square by itself. So to undo the square, we're going to take a square root. Our square and our square root will cancel. And we'll get x is equal to the square root of 8. What we have to remember is our plus and minus. But now we've already dealt with problems that looked like this, square root of 8. I'm going to do some side work. What is the square root of 8? If I break down 8, I get 4 and 2. 2 and 2. So the square root of 8 is 2 times 2 times 2. I have a pair of 2's. So x is really equal to plus or minus. My 2 comes out, and I'm left with 2 in my square root. And that is my final answer. X is equal to positive or negative 2 square root of 2. Number 10 will operate really similarly. I want to do PEMDAS backwards again. So the first thing I notice is I have a positive 3. So to undo positive 3, I'll subtract 3 on both sides. We always have to do stuff on both sides. So we have negative 5x squared is equal to negative 12. Negative 9 minus 3 is negative 12. Then 5 is multiplied by x squared, so I have to divide by negative 5. X squared is 12 over 5. Remember that a negative divided by a negative is a positive. And then we've got to get rid of our square. Take a square root of both sides, and I get x is equal to, don't forget your plus or minus, square root of 12 over 5. And this is why we had that whole video from before, because we've got to break down that 12 and the 5. So let's do, again, some side work. 12 over 5 is equal to square root of 12 over the square root of 5. If you break down 12, you'll end up getting 2 square root of 3 over the square root of 5. And then my square root of 5, remember that I really want a pair for that square root of 5. So I've got to multiply by another square root of 5. So I'll get 2 times square root of 3 times 5 over square root of 5 times 5. And in the end, I'll get 2 square root of 15 over 5. If you need to go back and rewatch that last video, please do that. But this is what I get, plus or minus 2 square root of 15 over 5. On number 11, when I'm looking to do PEMDAS backwards, the thing that I notice is that I have parentheses, which I haven't had in the last two problems. Parentheses is at the very, very end, meaning even though there's a plus 5, so there's adding and subtracting, I can't do anything to that yet. I have to work backwards. So besides the parentheses, there's nothing else to add or subtract. So I've got to look at multiplying and dividing. 1/3 is like dividing by 3, so I need to multiply both sides by 3 over 1. On the left side, I'm left with x plus 5 squared, and then 7 times 3 is 21. From here, I can look and see my exponents, take a square root of both sides. My square root and my square cancel, and I have x plus 5 is equal to plus or minus the square root of 21. Remember, every time you take a square root, you need to do plus or minus. Subtract 5 on both sides. Square root of 21 and 5 are not like terms, so I get x is equal to negative 5 plus or minus the square root of 21. Or if you want to write this as negative 5 plus the square root of 21, negative 5 minus the square root of 21. That might help you to see a little bit easier that those are really two answers. Moving right along, number 12 is also parentheses around my x minus 2, so I can't do anything with that yet. I've got to look at the fact that 3 is multiplied by this parentheses, so I can divide both sides by 3. I'm left with x minus 2 squared is equal to 7. And then again, I've got this square. What goes with the square is a square root. So to undo, take a square root of both sides. Square and square root cancel. I get x minus 2 is equal to, you guessed it, plus or minus the square root of 7. To get x by itself, PEMDAS backwards again, I do plus 2 plus 2. X is equal to 2 plus or minus the square root of 7. If you want to try 13 and 14, pause the video and just try these problems and then look at the answers. That is totally fine with me. I'm going to work through these pretty quickly. Number 13, PEMDAS backwards, I'm going to add 6 to both sides. 4x squared is equal to 48. Divide by 4 on both sides. X squared is equal to 12. Square, take a square root to undo that square. So I get x is equal to plus or minus 12 under the square root. A little bit of side work. 12 is 4 and 3, 2 and 2, which means that the square root of 12 is 2 times 3. So x is really equal to plus or minus 2 square root of 3, because we can grab this pair of 2's. So if that doesn't make sense to you, double check the last video. But our final answer is plus or minus the square root of 3. 14, I again have parentheses, so I've got to deal with this 1/5 before I do anything inside the parentheses. Multiply by 5 over 1 on both sides. And I get x minus 4 squared is equal to 30. I got to undo that square root, undo that square, so I do a square root. Those two cancel, and I have x minus 4 is equal to plus or minus the square root of 30. Do a little bit of my side work. Square root of 30 breaks down into 6 and 5, 3, and 2. So I've got 2 times 3 times 5. There are no pairs, so I'm just going to leave that square root of 30 as square root of 30. But I should add 4 to both sides. X is equal to 4 plus or minus the square root of 30. Oh, let there be light. So those are my two answers for 13 and 14. Again, I'm really just doing the same thing we did with equations way back in chapter 1. We're doing PEMDAS backwards. The only thing we've added is that now on PEMDAS backwards, we can actually look at the exponent and see what to do with that. So try the practice problems and let me know if you have questions.